Hello students, in this class we are going to discuss Bernoulli's differential equation or equation that are reducible to linear differential equation. So a standard form of Bernoulli differential equation is dy over dx plus p into y equals to q into y raised to the power n. Please remember here this n is not 0 or 1, otherwise it becomes linear. Now how we reduce this equation into a linear differential equation? Please note a linear differential equation is of the form of y prime plus p times of y equals to q. How we can convert this Bernoulli linear differential equation into this form is very simple. Let us see how we can convert this lean this Bernoulli differential equation into this form. So in order to reduce it into a linear differential equation, let us multiply both sides by y raised to the power negative n. So we can rewrite this as y raised to the power negative n dy over dx plus p sub x into y raised to the power 1 minus n, because we multiply both sides by y raised to the power negative n, and here exponent of y is 1, equals to q sub x into y raised to the power 0 or 1. Now, in order to reduce it into a simple linear differential equation, we simply substitute y raised to the power 1 minus n equals to v. Now, differentiate both sides with respect to x. We get 1 minus n into y raised to the power negative n into dy over dx equals to dv over dx. We simply substitute these two substitution in equation 1 and we get a simple linear differential equation of this form in terms of v, and after solving that linear differential equation we get final answer in terms of v, and then we again substitute this simple substitution y equals to y raised to the power 1 minus n to get the final answer. Let us see through a couple of examples, or we can simply let us see how we can substitute these number in equation 1. So this can be written as 1 over y raised to the power n dy over dx is nothing but 1 over 1 minus n times of dv over dx. So let us substitute these two values in equation 1. We get, in place of this, we simply get 1 over 1 minus n times of dv over dx plus p times of x into v equals to q. Now multiply everything by 1 minus n, we get dv over dx plus 1 minus n times of px into v equal to 1 minus n into q. Now this is a linear differential equation in v. Now we find integrating factor which is equal to e raised to the power 1 minus n into px dx. After finding integrating factor, we simply write solution of given differential equation, which is v times of integrating factor equals to q times of 1 minus n into integrating factor plus constant of integration. Now we put v equals to y raised to the power 1 minus n again to get the final answer. Let us understand this process through a couple of examples. So our first example is simply dy over dx minus 1 over x times of y equals to y raised to the power 4. So as discussed, multiply everything by y raised to the power negative 4 or divide everything by y raised to the power 4, we get 1 over y raised to the power 4 dy over dx minus 1 over x into y raised to the power minus 3 equals to 1. We simply multiply everything by y raised to the power negative 4. We multiply everything by this term. Now let us take y raised to the power negative 3 is v. So let y raised to the power negative 3 is v. Now differentiate both sides. So we get minus 3 over y raised to the power 4 dy over dx equals to simply dv over dx, or we can write 1 over y raised to the power 4 dy over dx equals to negative 1 over 3 dv over dx. So let us substitute this value and this value in equation 1. We get minus 1 over 3 dv over dx minus 1 over x times of v equal to 1. Now multiply everything by negative 3, or let us multiply first by negative 1. So it becomes positive, positive and negative 1. Now multiply everything by 3. We get dv over dx plus 3 over x equals to negative 3. Now compare this equation with the standard linear differential equation. We get p equal to 3 over x. So our integrating factor is simply e raised to the power 3 over x dx, which is nothing but e raised to the power 3 log x, or it can be written as e raised to the power ln x cube, which becomes x cube. So our integrating factor is simply x cube. Now our final solution is v times of integrating factor equals to integrating factor, which is x cube times of q. Our q is negative 3 dx plus c. Negative 3 come out of the integration. So it is negative 3 x raised to the power 4 over 4 plus c. And here v is y raised to the power negative 3 or 1 over y cube. So it becomes x cube over y raised to the power 3. Now transfer 3 by 4 x raised to the power 4 to the right side. We get x cube over y cube plus 3 by 4 x raised to the power 4 equal to c is the final solution of given differential equation. Let us do one more question. So this time we have a question: x square minus 2x plus 2y square plus 2xy dy over dx equal to 0. So first convert this differential equation into Bernoulli or linear differential equation form. So we can rewrite this. Let us divide everything by x first. So we get, if we divide everything by x, we get x minus 2 plus 2 over x times of y square plus this is simply 2y dy over dx. This equation can be rewritten as 2y dy over dx plus 2 over x times of y square equal to 2 minus x. Now let us put y square equal to v. Let y square equal to v. So we get 2y into dy over dx equals to dv over dx. Let us substitute this value in the given differential equation. We get dv over dx plus 2 over x times of v equal to 2 minus x. Now this is again becomes a linear differential equation, and our integrating factor is simply e raised to the power 2 over x dx, which becomes e raised to the power 2 ln x, or e raised to the power ln x square, which becomes simply x square. Now, solution of given differential equation is v times of integrating factor equals to q times of integrating factor. Here q is simply 2 minus x times of x square dx plus constant of integration. Here v is simply y square, so it becomes x square y square equal to 2x square. So integral of 2x square is basically 2 into x cube by 3 minus integral of x cube becomes x raised to the power 4 over 4 plus constant of integration. So this is the final solution of given differential equation. Hopefully all of you find it helpful, and if it is, I mean, if you find it helpful and you want any sort of help, then do subscribe this channel, and comment section is open for all your suggestion, feedback and query. Thank you.